I decided to talk about water first in this course because it is the most important nutrient that our body needs to take in. And I just want to start off by giving us a little bit of an overview of water and some of its properties that contribute to its essential functions in the body. So what's essential to know about water is that water is a polar molecule. So you are no doubt familiar with the molecular structure of water, which is H2O, i.e., there are two atoms of hydrogen and one oxygen atom bound together. You'll notice that water isn't like this. It's not like in its molecular organization, it's not just like a straight structure. It actually has this more triangular structure to it. And that's because given how the electrons are organized in water, the oxygen atom ends up being slightly negative and the hydrogen atom ends up being slightly positive in a water molecule. And this is really important because this makes water polar. It has a negative pole and it has a positive pole. And this is important because it helps it attract to other polar molecules like water itself. So the reason why H2O binds to another H2O to eventually make up like the water that we drink is because we have these differences in polarity attracting each other. So the negative hydrogen atom, the slightly negative hydrogen atom, is going to be attracted to the slightly negative oxygen atom, okay? All molecules that are polar are thus going to be hydrophilic. They're going to like water because of water's polarity. Conversely, molecules that are not polar in nature or non-polar molecules like lipids, they are not going to like water. They are not going to be attracted to water and in fact try to separate away from water. So molecules like that, like lipids that don't like water, those are considered hydrophobic molecules. You've probably heard before that our body is mostly water. Indeed, about 60 to 70% of our body by weight is water. And I remember always thinking about this concept of being like, how am I all water? Like, I'm not like Gumby or something. Like, I don't feel like I'm all water, and you probably don't either. But the reason water can make up so much of our body is because most of that water is found within cells. So if you remember your earlier science education in high school and elementary school, you probably remember that cells have a lipid membrane, and within those cells there's something called cytoplasm. Cytoplasm is like the cellular goo that all the cellular organelles suspend within. And that cytoplasm is mostly water. Since our body is made up of millions of cells, each of those cells containing water, that's how so much of our body weight can be made up of water. The remaining amount of water in our body, about a third of the water in our body, is found outside of cells. So these are supposed to be cells here, and outside of cells, there's something called the extracellular space. Extracellular, like not in the cell space. And in that extracellular space, we find water. We also find water in structures like our blood vessels, right? Blood is primarily water. The red part of blood is our red blood cells, but most of the content of blood is actually blood plasma, which is primarily water. Water can move from the blood vessels, from plasma, into that extracellular space. And blood pressure is the primary force that pushes water out of the blood through the spaces between blood capillaries and pushes that water out into the extracellular space. So blood pressure, like we see there, is pushing water out into the extracellular space. Conversely, there are things in blood, like charged proteins, for instance, or anything polar really, that is going to attract water into the blood. Okay, that it's going to pull it out of the extracellular space and into blood. So this gives you an idea of how water moves between our blood vessels and the extracellular space. However, the water that's found in our cells, it's pretty much stuck there. It's not considered a water source, something or a water reservoir that we can draw upon. Typically, the water that's found in cells stays there and it's not available for anything else.